Hi everyone, we'd like to begin our presentation on SENTRY, Set Embedding for Hate Speech Detection. Our team members are Amok, Yuri, Paritosh, and myself, Yoan. In today's presentation, we'll first introduce the motivation behind our research, then move on to our methodology and evaluation setup, followed by the experimental result and our future directions. Tweets are usually short, noisy, and full of slang or sarcasm. Labels themselves are also subjective and highly imbalanced, so single tweet models often fail to capture contextual meaning. For our experiment, we used three datasets: the hate speech and offensive language dataset, the dialogue hate speech dataset, and the MMHS dataset. Previous works mostly classify the individual tweets, but such approaches fail to capture inter-tweets relationship and context. Our approach instead models sets of tweets and further integrate direct preference optimization.
All right, let's start with the methodology. So we start with individual messages, which are passed through an encoder to get embeddings. But we notice that these embeddings can be very noisy at an individual level. So instead, we decide to create these set embeddings and pool them through mean pooling, attention-based pooling, or through max pooling. And once we have these set embeddings, we pass them through a classifier, in this case, an NMLP classifier, and we do the softmax and the logits to get the output classification. For the loss function, we actually have a multi-objective loss function where first we have cross-entropy loss, which is the standard supervised setup. The model learns to classify each input by comparing its prediction to the correct labels. Next up, we have DPO or direct preference optimization. Here, the model looks at a good and a bad example side by side, learning why one is preferred over the other. That pairwise training helps it pick up fine-grained distinctions. Finally, in set-based DPO, we take this a step further, and instead of looking at single pairs, we compare groups of examples. And we put this all together through our formula at the bottom.
Okay, so how are we constructing the set embeddings? First of all, we take individual embeddings, that is for the individual tweets. That is our baseline. Secondly, we take tweet set embeddings. So firstly, we randomize tweets into sets of 5, but then we do another experiment where we take an anchor tweet, two semantically similar tweets, and one negative tweet. So some negative hard mining that improves the accuracy and the recall for hate class as well. Thirdly, we take the user-based embeddings. So we have a separate data set for this, the Conan data set, which is the tweets based on each user. And finally, it's a theme-based embedding. So the different hate speech categories, like sexism and racism. Okay, so here we have the accuracies. If you see, it's ranging from 91.6, which is for the baseline, which is the individual tweets, to 96.4, which is the sets. Along with the DPO, it's performing the best. But if you see, there's a slight decrease in accuracy from 96.4 to 95.8 when we use the semantic tweets, which I've explained earlier. So if you see, although there's a decrease in accuracy, the recall is increasing. Coming to the next figure, if you see on hate class, we're achieving very bad F1 scores in all of the ablations except for semantic TPO. I mean, it shows a significant improvement from 58 to 67.7. So this somehow it's giving us an intuition to increase the data sites for the hate class. Also in the confusion matrix, most of the classes like offensive neutral are getting classified above 95%. Only for the hate, it's very ambiguous, ranging from 35 to 50%.
Based on our results, the first thing that we plan to do is improve the accuracy of hate label. And we'll do this by using permutation invariance, which is basically a data augmentation method. And we'd be augmenting the data from our hate speech samples. The second thing that we plan to do is use a dialogue data set from where our model will capture conversational tone and individual language patterns, and the MMHS150 data set to increase the overall broader semantic context for our hate speech data. So coming to the discussion, the first thing that we'd like to learn advice on would be how we can improve the overall accuracy for the hate category label. Second is when we are using permutation invariance, we'll be generating data with synthetic data using LLM. So how can we are there any specific techniques that that we can use to filter paraphrase sentences or sentences that are very similar or exactly the same from the LLM generated sentences? And third would be based on results, are there any other evaluation metrics for hate speech detection? So yeah, if you have any doubts from the slides or we are open for any Q&A discussions, please let us know. And thank you.